Today, we are going to be talking about how to prove triangles similar, specifically triangles similar. So before we get started, feel free to message me in the chat or shout it out. Can anyone tell me what qualifications we need for a polygon to be similar? Okay, so I'm seeing a couple things in the chat. One of the things I'm seeing is congruent sides. And while I like where you're thinking, we actually want our angles congruent and our sides proportional. In the past, when we've been doing problems with these, we've needed to know every measurement to be able to determine if our corresponding angles are congruent and our sides are also proportional. Today, we're going to talk about a couple different shortcuts that we can use. These shortcuts will work really well with triangles, but they won't work with other shapes. So let's keep that in mind. We are going to be starting on page 202 in your math notebook with activity 2, where we are exploring the angle-angle similarity postulate. So I'll give you a couple seconds to get that out. You will also want a ruler if you have one with you, or a straight edge. All right, is everyone ready-ish to begin? You can flash me a thumbs up or send me a message if you need a little more time. Perfect. Thank you, everyone. All right, so our first step is we're going to take a ruler and draw a triangle on a sheet of paper. You all should have them right next to your page on 203. That should be blank for a reason. And then we are going to label this triangle DEF. We don't really care what this triangle looks like. We just need it to be a triangle. And then again, it does not matter which angle you label D, but we need to have D, E, and F. Something else I should have mentioned, I apologize. It's been a long day today. We should have sent you some patty paper at the beginning of the semester. I don't think we've used all of it at this point, but if we haven't, we're going to need 2 slips for today. So take a couple seconds to get that patty paper ready, and then we will continue shortly. Okay. The next step we're going to do is we're going to take our patty paper and we are going to place it on top of the triangle we made. And then you're going to take your ruler or your straight edge and we are going to trace angle D. That is D as in dog. We'll trace that on our patty paper. Try and get it as close as possible. And we're going to want to extend the rays on this one. So make sure that your angle is opening really far, something probably as far as your patty paper will allow. Once you have your angle drawn, we're going to go to our top vertice up here, and we are going to label it G for goose. G as in goose. So we can match up angle D and angle G. All right. Now, we are going to look at our angle and we're going to find whichever ray contains point E. So for my triangle, it's this ray on the left here. We're going to look at that ray, and then we're going to place some point H. The key component here is that H cannot be right on top of E. So you can put it wherever the heck you want on this line, as long as it is not on E. I'm going to put mine a little further out. Once you place your point, we're going to label that point H. All right. Now that we've constructed point H, we're going to take our patty paper here, make sure that GH is on our line DE, and then we are going to slide our patty paper up, making sure our rays stay in the same position, and we are going to slide it up until points E and H are right on top of each other. So we should have a little bit of space right here between D and G. After you have slid your patty paper up, you're going to take your ruler and you are going to trace your line EF, and you are going to trace it all the way until it connects with your other ray.
Robert, you should be in Mr. Umfleo's Zoom room.
When you trace your line, you're going to trace it until that intersection. And we're going to call that intersection J. Now we have two triangles. We've got our triangle on the normal paper, DEF, and we've got our triangle on the patty paper, which is GH J. What we're going to do now is we need to check to make sure our angles are congruent. Since this is the angle-angle similarity postulate, we're going to check angle G, make sure that's congruent. We're going to check angle H, make sure is that congruent. And then we're going to check J and F, and we're going to make sure those two are congruent. All right. If you look on our activity sheet, down at the bottom, we have questions 6, 7, and 8. 6, 7, and 8 are for you all to do in preparation for discussion tomorrow. Since today's a shortened day, we don't have as much time as we would like, and these are going to be your homework for today, finishing up these calculations. So I'll leave just a quick note here. You want to measure in step 7, or 6, pardon. In step 7, you want to form your ratio and then I would use a calculator to divide. What I'm looking for on these 3 ratios, I'm looking for decimal answers there. Also, something to keep in mind, when we measure to the nearest millimeter. If we look on a standard protractor, the centimeters are the big gaps up top. So that's 1 centimeter. And the millimeters are the smaller gaps on the inside. Millimeters are a little more precise. So that's why we're going to be using those. Finally, on question 8, you are going to be comparing your ratios and using those to see if we have similarity. There is a spot for you to submit this on Canvas. Please have this submitted by Friday so we can talk about it during class. Yes. When you're doing your calculations, please know that we're expecting a little bit of discrepancies based on where you measure and where you round. So if your ratios are close, I think within 1 millimeter is what we've been saying, 1 or 2 millimeters, we're going to say that that's the same thing. So if we have, for instance, 1.6 and 1.7, we're going to say that's close enough to work. All right. I'm going to ask you now if you can flip to page 204. On the right side, you should see a page looking something like this. This one is still marked from last class. Let me grab a fresh copy. You should see a page looking something like this. And then directly to the right of it, on page 205, you should see a bunch of graph paper. We're going to be using that graph paper today to do this activity. The first thing we want to do is let's get a coordinate plane on our graph paper. I'm going to move that in here. And all we need for a coordinate plane, we need an x-axis, pardon. And we need a y-axis. It doesn't have to be super duper big. We just need to have a set of axes on there. And I will highlight these real quick just to make them stand out a little more. All right, now that we have our axes, our first directions say to plot the points A, B, and C. After we plot those points, we can use a ruler to form a triangle. So our first point is A. When we plot A, we go to the left 2 and down 1. Put a nice big dot there, and we'll label that A. Our next point is B. To compute B, or to plot B, we go to the left 2, and then we go up 3. 1, 2, 3. Remember, when we're moving in the x direction, a negative sign goes to the left. And when we're moving up and down, a negative sign goes down. We'll label our point B. Our last point is C. To get to C, we go 4 to the right, and then we go 1 down. Now that we have our points, A, B, and C, we're going to take our ruler or straight edge, and we're going to connect the dots. After connecting the dots, we should have a triangle like this, where we go up, we slant down, and then we come over. The next step we can do here is if we look on our paper, we are told that the coordinates of D are the coordinates of point A multiplied by 2. What we're going to do is we're going to say D equals A has the coordinates -2, -1. So we're going to multiply each one of those by 2, and those are going to be our coordinates of D. So our x coordinate is -4, and our y coordinate is -2. To get point E, we're going to take point B multiplied by 2. And to get point F, we're going to take point C multiplied by 2. After doing those calculations, we get E equals -4, 6. We get F equals 8, comma, -2. After we plot these points, after we find these points, we need to plot them on our graph. To get point D, we start by going to the left 4 and down 2. Make sure you're labeling all these points here. To get point E, we go to the left 4 and then up 6. And then to get point F, we go to the right 8. 1, 2, 3, 4, 5, 6, 8. And then we go down 2. After we have our points connected, our points plotted, we can connect the dots. And we get this larger triangle, DEF. Now that we've constructed the two triangles, the rest of the problem, or the rest of the investigation, is up to you to finish. We'll need you to calculate the lengths and then write the ratios. After you write the ratios, you can decide if the sides are in proportion. And then after comparing the angles, which is step 7, you can use that information to decide if the triangles are similar. Something important I want to note here. For these first 4 segments, so those are going to be our vertical segments and our horizontal segments. For those segments, all you have to do is count the squares. However, when we look at our slanted segments, you can't just count the squares here. We need to use our distance formula to calculate this. From what I understand, you learned the distance formula in semester 1 in your first or second chapter. But just in case you don't remember it or you don't have those notes on you, we can say that the distance formula is D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. You might have it in your notes as x2 minus x1. That's completely okay. Since we decide which point is x1 and which point is x2, you can switch it around. It is entirely up to you. As long as you are consistent with which point you choose for y1 and y2. So, the rest of the activity is yours to finish up. Something else to keep in mind, you could also use the Pythagorean theorem to solve for BC or DF. And the Pythagorean theorem is a squared plus b squared equals c squared. Either of these work. We'll just need you to use one of them when calculating the lengths. Again, you only need to use that for these last two, our slanted pieces. Let's move on to our last activity of today. That will be on page 206. It will look something like this. You will need another piece of patty paper for this activity. So I would get one of those out. I'll give you a couple seconds to do that, and then we'll get started. All right, let's get this one started. Our first step is we take our ruler and we can use our ruler to draw a triangle on our sheet of paper and label it ABC. Again, it does not matter what your triangle looks like. You can have it look like whatever you want. I would recommend having this one a little bit bigger though. Yes, this triangle will need to be on page 207 in that blank space we've provided for you. Once we have our triangle drawn, we can label it A, B, and C. After we've drawn our triangle, we're going to take a sheet of patty paper. We're going to place it right on top of our triangle. And we are going to trace angle A. I would extend the rays on this one. Once we have our angle traced, we are going to label it angle D, as in dog. After you've traced your angle, we're going to take our ruler and then we are going to measure the segment of AB. Again, we want to measure using our inches, our centimeters and millimeters. And then we'll write that measurement down. So this one, mine is about 2.7. And then we're going to repeat the process for line AC. we're going to say that one is about 5.2. We can record those on our sheet of paper, 2.7 and 5.2. Whatever your lengths may be, these are just what mine are. After you've measured your lengths, we're going to put our patty paper back on top, and we are going to find the point that is half the length of our original side. So for my side AB, my length was 2.7. Half of 2.7 is about 1.4. So I'm going to put a mark at 1.4. And we're going to call that point E. We're going to do the same thing on our segment AC. We are going to put a point at about half the length. So my AC was about 5.2 centimeters. So I'm going to put mine at 2.6. Again, these values will change depending on what your shape looks like. You could have different numbers than me. Take another 30 seconds to get that finished up. After we get our 2 points placed, oh, and we'll label this second point, this point on AC, we're going to label that F. So the last thing we do is on our patty paper, we're going to take our marks for point E and point F, and we're going to connect them. Giving us this smaller little mini triangle. Our triangle DEF. All right. Now that we have our two triangles, that we've constructed two triangles, finding the rest of our measurements will be your job for next class. You will need to find our measurements, which you can do using a ruler. And then calculate our ratios. Remember, we're looking for a decimal here. And if it's close, like if we're saying it's like 0.6 and 0.7 are the two calculations, then you can say that those are the same thing. After you've found the ratios of sides, we will decide if they're proportional. And then you can use your patty paper to check your angles. You can use that information to answer question 11 down at the bottom. That is all we had for today. So in conclusion, what we need from you for next class, we need you to finish the measuring and calculations for all of the activities we did today, for our angle, side, and side angle, side. There are spots for you to submit that on Canvas. Something else to note is that because this was taking a little longer than expected, The riddle assignment that was supposed to be turned in tonight is now extra credit. You do not have to do it. Does everything, are the assignments clear? And do we feel fair to decent about everything? You can flash me a thumbs up or, yeah, okay. Awesome. Since this is all we have for today, I am going to start running through attendance. If you have questions, please stick around. We will be happy to answer them until 12:12. Otherwise, you are free to go. And yes, Antonio, this will be due tonight. So I'll need these 3 activities submitted tonight. We'll be talking about them in class on Friday.
All measurements are in centimeters and millimeters.
Yes, sir, Mr. Girth. All right. I'm going to start running through attendance now.